Okay, today we're talking about function operations, and we're going to teach you how to add, subtract, multiply, and divide functions, and then we're going to teach you about special circumstances called composition. So first we're going to look at function operations. We have two functions up here. We have f of x equals 2x minus 5, and we have g of x equals 3x plus 4. So when we do addition, we would say what happens when we add those two functions. So for addition here, it says f plus g of x, which is the same as f of x plus g of x. So I'm just going to write what f of x is, which was 2x minus 5. And since it's addition, I'm just going to put a plus, and then it says we're adding it to whatever g of x is. So I'm going to put 3x plus 4 in parentheses next to it. And the question is, what does that equal? Well, we're adding them, so we're going to look and see if there are any like terms. We have a 2x and a 3x, and we know that those add together to 5x. We have a negative 5 and a positive 4. And negative 5 plus 4 gives me negative 1. So that's our answer. That's all we had to do for addition. For subtraction, f minus g is the same as f of x minus g of x. So again, I'm just going to write it down, 2x minus 5. But in this case, I'm going to put a minus sign in between, and then my 3x plus 4. Now, one thing to be careful of is this minus is going to have to apply to both of them. We think of that like distributing. So, if we do 2x, take away 3x, well, that's a negative 1x. And then if we do negative 5, take away 4, remember, because we were distributing that negative. So negative 5 take away 4 is negative 9. And that's it, and that's our answer. For multiplication, this is going to look really easy and really similar to what we're doing. Again, we write the f of x first, 2x minus 5, times the g of x. And we don't even have to write in between, because we know this what it looks like. Well, now we just have FOIL, which we've done time and time again. FOIL. First things in each parentheses. 2x times 3x is 6x squared. The outside, 2x times 4 gives me plus 8x. The inside, negative 5 times 3x is negative 15x. And the last part, negative 5 times 4 is negative 20. The last step, we will combine the like terms. In this case, our x's, so we would have 6x squared minus 7x minus 20. All right, division. Division is going to be probably the easiest one of all. We just write our division. So f of x on top, so that's 2x minus 5, and I'm just going to put in parentheses. Over. Our g of x is still 3x plus 4. Now, we reduce if we can, but in this case, we can't reduce. Those binomials are not identical. We can't break off any parts of it. So we're done. So I'm going to skip composition for a second, and we're just going to go over some examples. We're asking for these examples, let f of x equal x minus 2, and g of x equals x squared. So f of x, and it says we're adding. So that means we're going to add f of x, which is x minus 2, to g of x, which is x squared. And in fact, let's keep this consistent, and I'll put that in green. So when we add them, there's nothing really that combines. There are no like terms. So all we have is our x squared plus our x minus 2. And now you might have an example that says, okay, well, evaluate for 3. All we have to do when that happens is write the formula, which is what we have written in red. Now we're going to plug in the number in parentheses for x. So if the number in parentheses was 3, then that means I'm plugging 3 in wherever I see x, and I just evaluate it. I'm going to simplify, combine like terms where I can. So 3 squared is 9, plus 3 minus 2, so it's 12 minus 2. So that gives me 10. So if I'm plugging in 3 into that function when it should give me 10. Let's try one more. This one says f times g. So again, that means that we're doing f of x times g of x. Well, in our example, f of x is still x minus 2, and g of x is still x squared. So if we multiply that out, then we would get x squared times x, which is x cubed, and x squared times negative 2, which is negative 2x squared. Then we would, if we wanted to know what would that be when we plug in negative 3, again, we're going to write the formula and evaluate for what's in parentheses. So we're taking this formula that was in green, that's what we got when we multiplied these two out, and we're going to put in that negative 3. So negative 3 to the third power minus 2 times negative 3 squared. And if you plug that all into your calculator, you're going to get negative 45. Now for example 3, we have f over g, and again, division's probably going to be the easiest one. So again, our f was x minus 2. I'm going to be consistent and write that in blue. And we're going to put that over our g, which was x squared. Now, if we want to evaluate it for a number, let's say 5, again, we follow those same steps. So we're going to just plug that number into the parentheses. So 5 minus 2 over an x squared would be 5 squared. We're just plugging in this 5 wherever we see our x. 5 minus 2 is 3, and 5 squared is 25, and that's your final answer. And then we'll do a subtraction one. Should be pretty easy again. So now we're doing f of x, so that's x minus 2 minus g of x, which is x squared. And in this case, again, if we don't have any like terms, then we're just going to end up putting them in order. And we always put the highest power first. So negative x squared, and then we have a positive x and a minus 2. That one is done. So if we want to evaluate it for negative 2, we're going to plug that in wherever we see x. So negative, because there was a negative out front, negative 2 squared plus negative 2 minus 2. Now again, you can put this whole thing into your calculator. It should tell you negative 2 squared is 4. It'll actually take you all the way to the final answer. And we have negative 4 plus negative 2 is negative 6. Negative 6 minus 2 is negative 8. And that's your final answer.